Hello, welcome everyone. I'm pleased to welcome you for this 42nd Nmrg meeting. The topic for today's meeting is next steps in autonomic networking. It's a 1-hour session, so it will be a bit short, but we have today 2 presentations. First, the Notewell, which are all aware, but please be not this well. Quick overview of the agenda for today. I'll take a few minutes just to give a status on the research group activity, and then I will introduce the first speech of today, self-driving networks from Curatic Umbrella Networks. And then we will have a second presentation by Jefferson Nmrg on the autonomic networking retrospective. And the remaining time will be allocated to an open discussion, try to identify the gaps, challenges, and define a roadmap for the next step in autonomic networking. So a quick research group status. We have a couple of active IDs that have gone through research group last call beginning of this year, and this has passed and is currently ready for IRSG review. This will be channeled to IRSG after this meeting. Then we have also a second draft on IPFix Nmrg location. This draft was in IESG conflict review and has gone through that. Outcome is that it needs to go through the IETF review and IESG approval, so we have a bit of work to push this draft forward. Important information, the next meetings for the Nmrg. The next one will be organized together with the IEEE IM conference. It will be in Lisbon, second week of May. We will have 2 sessions there. The first one will be on Tuesday, 9th of May, which is mainly an introduction to the newcomers, trying to recruit new participants to the Nmrg. And we will have a second session, which will be a technical session for Nmrg. And one option is to be a follow-up of the discussion of today. We plan to have also a meeting in Prague, dedicated to a workshop on measurement-based network management. This is a series of workshops organized together with Nmrg, and possibly based on the feedback, also an additional session on another topic. We also plan to have an Nmrg meeting in IETF 100 in Singapore end of this year. So topics remain to be defined, but there is also some people suggesting to have a full-day workshop in addition to the IETF meeting on a intent-driven networking. So we will try to post more information on this proposed workshop as it progresses. Final slide for the research group status. We will continue to develop and focus the research group on a set of key topics. This is ongoing work, and we plan to share the research agenda we are doing together with Lisandro as soon as possible. But we need your inputs and feedback. We have posted some elements end of last year on the mailing list, so we appreciate your feedback on that. And of course, we will try to build upon this the outcome of today's meeting. So that's the end for that. I would like to ask Curatic to come and have his presentation on self-driving networks.
Thanks. And thanks for inviting me here.
You're welcome.
Okay, so this is kind of a vision, an idea that, don't ask me how to actually do this quite yet. I have some ideas around this. But I do want, I've been talking about this for almost 18 months now. And I want to get beyond talking about it to thinking about how we might realize this. So next slide. So I made a presentation at the MPLS World Congress a year ago. So this is the first public presentation about self-driving networks. And the way I think about this is I draw an analogy with the self-driving car. And there was a vision, which was DARPA's Grand Challenge, which happened in 2004, to where we are today, where everyone is trying to get into the act. And so the question is, what kind of trigger would it take for us to start building this? And beyond that, when can we actually see this in action? So next slide. So this is the self-driving car journey. You might have to click through it. In 2004, DARPA issued a grand challenge saying, can you build a self-driving car? They basically wanted the car to drive itself with no human intervention, 240 kilometers on a deserted stretch of, on a stretch of freeway in the Southern California desert. But they did make sure that there's no other cars there, so only the robotic cars. It's a very simple, very well-contained problem. But the first time around in 2004, nobody could do it. They redid the challenge in 2005, and 5 teams actually succeeded. But and then they went on from that to the Google car that you see there, or call it Waymo, I guess is a better term today. So in that period of 10 years, you have a fully autonomous car. So this car doesn't have a pedal, doesn't have a steering wheel. It really has to drive itself. Now, of course, along the way, they took a Lexus and put a bunch of stuff on it and showed you how the Lexus could work. But they do say that, hey, you need a driver, and in case the robotic robotic driver could not do it, the human has to take over. With this car, the only thing the human can do is open the window and jump. From what I understand, I've not actually driven in this. Next. So the thing is, what would a self-driving network do? And so the first step is you accept guidance from a human operator. Now that you have this autonomic network or a self-driving network, he can be anywhere, or she, and in a hammock at the beach drinking a Mai Tai. That's perfectly fine. But the rest, everything else would be done by the machine, by the robot. And we talk a lot about zero-touch provisioning, and you said at the beginning, autonomous networks. We have another group called Anima. But I want to go beyond all that. Yes, you do have to figure out what the pieces are, put them together, and self-configure. But you also have to detect that something changed. You have to say, hey, a customer came on board. You have to provision that customer. You have to monitor that. If the customer's service is not up to snuff, you've got to do something. If a router crashes, if a link goes down, you have to figure out what to do. So everything that a human operator does should be done by this thing. So that's the idea of a self-driving network. So it's not any one piece of this, and it's not any one small part of the network. It's the entire network being completely manually run, completely automatically run. Next. So to do that, again, drawing an analogy with cars, I think that these 5 basic technologies that are needed. The first is telemetry. The second is multidimensional views. So having independent telemetries is fine, but you really want to put them together and start, getting more insights from your network. The third is automation, and that's fairly clear. The fourth is declarative intent, and this is now a very, common buzzword, much better than the SDN buzzword. By the way, I should point out that self-driving network is another expansion of SDN. So if you don't like the first one, you can use this one. Carefully chosen, yes. But declarative intent is really important. And I think we put our fingers too deeply into networks, and we should be able to step away and let the network do its thing. And the last is decision-making. And decision-making can be rule-based or can be machine learning-based. But ultimately, I have all this information, great. If that information is just sitting there and doing nothing, it's not helpful. We need to get to the point where we can make a decision based on this. And ideally, the machine will make the decision on its own. And can use a rule-based system, or can use machine learning, or can use a combination. And the Google self-driving car uses a combination. So next. So I'm going to start with telemetry on cars. And there's the usual thing. There's the speedometer, there's a gas gauge, there's the tire pressure sensors, there's a tachometer, which I didn't put up here. These are all helpful to give you some idea about how you should be driving. Maybe you should change gears. You can hear the engine is working too hard, or you can look at the tachometer, or you can look at the speedometer and say, maybe I should speed up, maybe I should slow down. More recently, people put a radar so that you can have this smart cruise control. So not only will it maintain the speed, but if the car in front of you is slowing down, it'll slow down. Today, I'll just run into, well, not today, but a few years ago, we'll just run into the car in front of you. Sonar for parking assist, cameras for all kinds of things like, finding out who hit you. These are all to help a human drive. But when Google said, I want the car to drive itself, they asked, what kind of telemetry do I not have, which would be really useful? And so they put this thing called a LiDAR. The LiDAR is $80,000. They put this on a Lexus, which is $70,000. So you had this LiDAR, you had dual cameras for stereo imaging, you had a very powerful PC. All this other equipment they put on the car for self-driving was $150,000. But the LiDAR was the biggest, most expensive part. And for those who are curious, you can Google, you can search for Google or Waymo, Uber, and LiDAR, and interesting stuff will pop up. The reason I put this up here is when we talk about telemetry, we're talking about telemetry that will help a human operator run the network more efficiently. But I think we also need to talk about what is it we're not thinking about if we really want the network to run itself, the same way that Google sort of came up with the LiDAR. So here's, I think, where we are today in parts, where we could be. Essentially, and stop right there, yeah, thanks. You have out here, oh, I'm not in the box. Is that okay? I'll get back in the box quickly. You have in here a collector, and you have here a network element. And basically, rather than doing SNMP queries all the time, you should be able to tell the box, this is the kind of information I want, and it'll come streaming to you in real time. So you don't want to be polling for this. And so you want the telemetry to be really efficient, very efficiently encoded, and you want it to be coming at you all the time so you have a sense of what's going on. And I think this is a very critical part. Today, we get information in parts, in places that we think are useful. We dump them into a database. We then take the disk and bury it somewhere deep in the ground so that if someone asks for it, it's there, but we don't use it again. And I am being facetious, but we need to do much more. The second thing we need is this multidimensional views, which is the next slide, which is not just get this piece of data here and get some other piece of data there and get some third piece of data somewhere else. but be able to correlate these. So you can correlate across layers of the network. You can correlate across geographies. You can correlate what's happening at a peer with what's happening inside your network. You can do time-based analysis, trending. So you know what's normal, you know what's the baseline, and you know what's maybe not normal. And so that gives you a hint. Maybe I should look more into why the traffic changed, or why this user is talking to the other user where he's never talked to that person before. So it's not enough to get the data. It's important to pour that data into a data lake, which is an expression that people use, where you can correlate these things, and you can get much deeper insight from the data that you have. The third is automation. And so this is an example. I had to slightly sanitize this. Hopefully I've done a good job. But this is an example of a device, a network element. At the bottom, you have the hardware. You have the chassis and the line cards. Above that, you have an OS. And above that, you have a number of things. And networking is bringing to our OSs and our software things that are typically seen in servers for server automation. So you have Ansible, Puppet, Chef, Salt. You've got Python scripts and Ruby scripts. And then, of course, we've been moving in the direction of netconf or restconf. So you can operate the box remotely. You can operate the box from a more centralized thing. So when everyone says CLI is such a horrible thing, well, you don't have to use CLI, or your CLI can just be an internal netconf call from within the box. But all of this allows you to start automating and understanding how to upgrade a whole bunch of devices all together, or make the same type of change on a number of devices instead of having to log into each one. So automation is really important. Again, the analogy with cars, if you look at the Google self-driving car, the Waymo car, it's an electric car, so it doesn't have to worry about gears and stuff. There's a number of things that become much simpler. But even if you didn't have that, if you had to have a physical pedal moving thing, so sort of a foot that was changing gears for you, it'd be much more complicated than if you could just tap into an API and make the car stop or change gears or whatever. So automation is really important. The next is this declarative statement of intent. So in the car, if you don't have a pedal, if you don't have a steering wheel, what are you going to do? Well, you have a little dashboard, and you can say, I want to go to the airport. Hey, I'm in a hurry. Take the fastest time. Or I'm a cheapskate, so take the path that doesn't have any tolls. Or like me, I'm in a Leaf. I'm always like, I've got range anxiety, so find the way that'll have the least use of battery. But whatever, I mean, you sort of say, this is what I want, and you might give some hints about how to get there, rather than giving all the details of, you should take 101. I'm in the Bay Area, so I would take 101, and I'd be in the left lane, except for this place where I know I need to go to the right lane. I should exit here, I should get on there. All those details you don't have to worry about anymore. But of course, you can go even better and say, hey, car, just talk to my phone. It'll tell you what my next appointment is, and just take me there. So, I mean, this whole thing about intent, you can get higher and higher level intent. So I've talked at, I think it was the Nmrg a few years ago about, I don't think it was Nmrg, about SDN as a compiler, where you essentially give a high-level declarative statement of what it is you want to do, and then it will compile it, process it, and say, okay, device 1, device 2, device 3, here's what you need to do. Today, we just get on the device and start typing at the CLI. So we're focused on how, not what, but we really should get to the what and say, this is what I want, how you do it, I don't care, that's your job. And the last technology is this decision making. So you have this idea of either rule-based learning or machine learning. Rule-based learning, you put down some simple rules, if this, then that, and then you say, oh, that didn't quite cover it, so I'll put another condition, if this, then that. And as you keep putting these conditions down, each one is very, very simple, but very, very quickly it becomes very complex to handle. In principle, it's also very deterministic. So you could read this, this set of if this and that, and say, I know what this is doing or what it'll do, but it is very, very cumbersome. In machine learning, you say, I'm going to walk you through something. I'm going to show you how I would do it, and I'll give you a million such examples. Then you can learn. And so, according to Alan Turing, this is the essence of artificial intelligence. It can become very creative. Machine learning has become really, really powerful. Part of that is we have much more data today, and part of it is we have much more powerful computers. We have a few better algorithms, but the algorithms are actually the least of it. So it is a very fast way to learn complex behavior. The problem is we don't know how it got there, and we don't know what it'll do. So typically, you pair the machine learning with rules. So you say, drive, stay within the white lines and do all that, but you'll put a rule saying, do not kill a human if you can avoid it. And of course, there's a whole bunch of questions about if you do have to kill a human, which one would it be? The passenger, the little girl here, or the old man there? It's like, and so now they actually have courses in ethics of machine learning. No jokes, this is serious. Okay, so these are the technologies. I also see sort of like they have 5 levels of autonomy for self-driving cars. You can kind of put up 5 levels of self-driving for networks. You have completely manual stuff, which is, I think, where we are mostly. We do some automation. If you're gathering all this data, you can start crunching on it and visualizing it, at least have a sense of what's going on in your network, where are the hotspots, how do the hotspots move around during the day, during the week. If you go further, you can analyze this and start getting some deeper insights. You can make maybe some predictions about where you would have to add capacity in 3 months or where things are happening. The next is recommendations. So if you think of this as a closed loop system, I learn stuff from the network, I operate on it, and then I make a decision. Rather than making the decision yourself for the machine, you could tell a human, this is what I would do, and then the human could say, based on their experience, yeah, this is a good thing to do, or no, you don't have enough data, I should take over. But at the end, we want to get to it's totally self-driving. And so this is what they call level 5 autonomy for cars. Anyway, so how do we get this kicked off? Well, if we take the model of the grand challenge, I would propose a networking grand challenge. And yeah, thank you. Yes, this is fine. So this is a very, very high-level architecture of how this might work. And this is the closed loop that I was talking about. So you get data from the network, you analyze it, you make a decision, or you go through a decision module, and you take some action back in the network. And if you do this, then you're constantly optimizing. So based on what your intent or what your high-level declarative statement is, I'm going to constantly go through this loop. Oh, a new customer came on board, new subscriber came on board. What do I need to do? I did it. Monitor. Yeah, that person is happy. No, they're not happy. Make some changes, and you keep going. I do want to stop there for a second because I think this is where there's a lot of work for us to do. If you're gathering a lot of information, this telemetry has to be really efficient. We need standardized data models. And to a large extent, we try to do telemetry for human consumption. We got to stop doing that. Okay, so we really need to move on to putting this data in a format the machines can understand and can do the analysis most efficiently, and then they can present it in a format that's useful to humans. Also for the actions, we need to say, how do we interact with the box? What kind of things do we do? Okay, next. So here's, keep clicking through. So the grand challenge would be, here's what we want to do, self-driving network with whatever definition. I don't have a price, but we'll figure that out. And the result would be to free up people to work at a higher level, to do service level definitions, to do new service design, to maybe learn how to tweak the AI to work better. The result would also be a much more agile infrastructure, which can anticipate things because it has this prediction engine. And maybe the most important is fast, intelligent response to security breaches. And so here's an example, but pick your favorite little thing and say, can we go build that? The things that I want you to think about, not just the technology, but what is the impact and what are the possibilities? What can we do differently? I mean, completely differently from what we do today if we had a self-driving network. And the next few slides have some examples of that, but this is really where you need to think about things. So, for example, there's a huge skill set change. I'm an OSPF geek and I know how to set metrics, not important, but I need to be able to create a new service or tweak the AI, and so on. You can read them. The next is a sort of crazy idea that for the next, so I will tell you that the Olympics for 2020, the planning started in 2015. And this kind of 5-year cycle planning for a big event is probably not the right way to do it. It would be great if you could wake up and say, oh, the Olympics are tomorrow, order a few things. They will come on a self-driving truck. They'll set themselves down, self-organize, do what they need to do, and then they go away. So that's basically it. I think we have a compelling vision. I think so. There's an economic imperative to make OpEx really, really much lower. There's an efficiency imperative. There's an agility imperative. There's a security imperative. So we need to get to work. Question?
Yeah. Thank you, Katie. I think we have a few time for questions. It's important.
Mike.
Hi, Giovanni, SIDM. So I'm not really familiar with that, so I'm kind of new to that and trying to understand. What is the difference between your proposal in relation to other technologies like autonomic networks? What is really new in here? I just try to understand here.
So what I'm thinking of, and I have to apologize that I haven't followed autonomic networks. I mean, I randomly get into the animal working group or this working group, once in a while, or research group. What I'm looking at is a completely self-driven network, which means that everything that human operators do in the NOC, whether in the central office, in the POP, in the core, all of this should just happen automatically. And at some level, human operators are still needed, but they're going to define things at a much higher level. They're going to say, here are the applications that matter to me. Here are the customers, subscribers that matter to me. Here are the peers that matter to me. Here's my resources. How would you organize yourself to maximize happiness or whatever, given this finite resources?
Okay, thank you.
Yes, it's a small question. From the model you have shown, how much have you already implemented or experimented with? Do you have any testbed or something like real thing?
So what I've started playing with is looking at bandwidths and trying to come up with a time series model for them. The problem is I don't have enough bandwidth. Okay. Right? I need data for 6 months or a year. Here's two things I want to do with the bandwidth. One is to make, if you do a time series analysis, it'll tell you these are the patterns. Okay, there's some errors from the pattern, and here's the long-term trend. So from the long-term trend, I can say for this, for LA to New York traffic, I will have to upgrade some ports in 6 months or 3 months or whatever. So I can do some predictive analysis. The second thing you can do is to say, this is normal traffic on Monday at 10 a.m. And if I know that the traffic, on this port on Monday at 10 a.m. is between 3.5 and 4.5 gig, plus or minus. Okay, self-driving networks would not do that. The rules would prevent them. So if I know that the traffic at a certain time would be between this range, and the traffic is significantly higher or lower, it would tell me you need to go look at that. And this is data that's available today, but people don't do that kind of analysis. So that's just the front part. I do want to do other things like do syslog analysis using machine learning and say, what is the root cause? So instead of doing root cause by rule-based systems, which is typically how they were done, I think some people are trying to do it differently. I want to use I want to use machine learning to analyze syslog data and say, this is what happened.
Yeah, related to that, you have mentioned time series analysis and machine learning. Have you considered other kinds of, for example, expert systems that can be even smarter than any machine learning algorithm that are, from my point of view, are actually really silly in comparison with any expert system that is fed from a human during some long period of time, and after that you leave the system running itself. So
I'm not at all against any technique. So really, I don't want to get into how to build this. The first step is to say, let's all seriously build not just an autonomic system here. Let's take all of our networks and make them self-driving. Now, how you get there, I think we'll find as we do it, we'll need different technologies. Expert systems have a problem that you have to have humans, give you a lot of guidance.
Teach them.
But so is machine learning, because machine learning runs typically on label data, and you need humans to label the data. So there is no ideal way of doing it, but I think we really say, when DARPA made the challenge, they didn't say use this technology. They said just the car should drive by itself.
Yeah, but even we humans do not learn by ourselves. Somebody teaches us.
Yes,
So,
yes.
okay, I will stop because
Okay. Definitely a lot to discuss, yeah.
Dan Drutz, AT&T. Interesting vision. I think the analogy is pretty appropriate. Though I'm thinking that technically, just like with the autonomous car, there are probably networks that are pretty self-sufficient. It all comes down to legacy, scale, and these are the kinds of challenges. The reason you don't see cars on the road today, or they're being pushed out from the road, like yesterday was just, or the day before, Uber canceled all their experiments because they got a crash. And why? Because usually the humans are the ones that making the accidents. So extending your analogy, usually is the problem is with your legacy system that may have interference with your learning and self-driving network. Legacy is a big issue because you got investments in there,
Yes.
and I think what you're just putting on this vision together, the bits and pieces are there. Maybe we're not using them efficiently. Maybe we're not using them coherently, but they're there. So what is the deterrent? The deterrent is what I just said: scale and hybrid legacies.
Yeah. Well, yes and no. Today, there's a lot of human operation, and it's not only because it's legacy. The question, I think, is just as for the car. When I went from a clutch-based system to automatic transmission, I made it easier for a human to drive, but the car still doesn't drive itself. It's when you start thinking about what does it take for the car to drive itself. Yes, I have these bits and pieces, but I really need to have that thing. I do not want to have a human involved.
Sure.
I think you start looking at things very differently.
We also have a vision. We made it public. It's called Project Indigo.
Yeah.
And that's pretty much along the lines of what you're just presenting.
Cool.
Thank
That's
you.
good.
Well, a couple of reflections. One is when it comes to making whatever the technology you're using when you want to make this learn. One of the problems that at least we have started to face in some experiments we have made is about data, about the availability. No, it's not only about the availability of data, that is complicated to get.
Yeah.
And it's very complicated to share and to convince the people that own the data to share.
Yeah.
But it's about the fact that when you have a lot of raw data without tagging, without labeling, this basically is having nothing. I mean, well,
Not
more than
much.
nothing, but
But not much more.
well, then what we have decided to start inside our lab is something, well, I don't know if you have read about the immortality. It's something that we call the mouse world. The idea is that you have something in which you can play with things that, well, since you don't care because I like mice, you can do whatever you want to do, with the idea of, on the one hand, generating data sets under control conditions, and second, generating noise, but noise that we know, that is a now noise
Yes,
that we
yes,
can
yes.
combine. We're making an experiment of this. We are trying to get support, and it's for you and everyone here. If we can talk about trying to make this evolve. I mean, it's a let's say a smart learning environment, so to say.
Right, right.
This is one thing. Second is because when I was younger than now, not so long ago, I made my PhD thesis on fuzzy logic. And well, Lohan, don't because I found that there is an ideal combination of one thing is the possibility of machine learning and the possibility of having human language, having it is intelligible what you find. Well, again, I don't know if you have considered it because it's something that they see extremely powerful. It's not so in fashion right now, but I find it extremely powerful because it's this combination of the ability to learn and the ability to express what has been learned in something that is close to human language. So.
Okay. Thanks for the comments. I will say two things. One is I went to my first conference in machine learning. And yes, it was machine learning. It's NIPS, Neural Information Processing Systems, in Barcelona, not so long ago. And I do want to go to more, but the problem there is they want to polish a diamond even finer. And I don't want an algorithm that's like 10% faster and 20% more accurate or whatever. But there are some other things they're doing that are really interesting, which is multimodal learning, using different techniques and using different types of data. So if I'm trying to understand what you're saying, but I only listen to the voice, I'll have a certain accuracy. But if I'm also listening or seeing your face,
yes. Mm-hmm.
so I can do better. And how can I apply those techniques in the network? So I get some data from the routers, I get some data about traffic. How can I put that together and make a better inference about the network? And I'm not wedded to machine learning. It's just that machine learning is in the news right now, and it's very, very powerful. You're right that it's really, really hard to get lots and lots of labeled data. There are techniques for semi-supervised learning. And so you have some labeled data, and then you try to extrapolate. But that is the biggest problem. But I think the second problem is for us networking guys. We collect some amount of data. Sometimes we collect lots of data, but we don't use it as efficient as we could. So I think if we even start looking at that and start understanding our networks better, would be better off. But if you're willing to share your data, I'm happy. Yes, we should talk.
Well, this sharing the environment for generating data.
Oh, okay. 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 Yes. Small difference. Yeah.
Hey, Lu Yuanfang, eBay. So since Diego and you all mentioned the background, I wasn't intent to, but there was a comment on expert system, knowledge-based system compared with the machine learning, the more deep learning stuff. So my master was expert system, my PhD was in neural networks. So the neural networks with the deep learning, it's much more capable. So you don't all rely on to getting all the knowledge from the expert. Pulling the knowledge from experts is difficult. So that was long, long ago. Recent years is all networking. And now what we're doing is, I think I'm very, that's what we're doing actually, including the bandwidth you mentioned those things. We actually have the time series data. As Diego mentioned, the data is not completely clean. It's not complete, right? Some portion maybe not there. Some equipment saying I cannot support this. And the data is, SNMP. It's very heavy. And everybody has a lot of data sitting, under, but it's hard to process, it's hard to deal with, because when I first pooling, saying, okay, let me look the whole data set. Oh, that's too much. Let me look one, cluster. Oh, that's too much. Let me look one device. Let me look 24 hours. It's way beyond a million points. So the data points, there's a lot of data points because you continuous collect that.
Yeah.
And also the SMP is cumbersome. It's the pool model, right? So all these things, the telemetry is one important thing. So the point I resonate or want to make today, what prevent us in the past to go far, to scale with the AI machine learning? It was machine speed not there and big data not there. Today we have big data, but we're not mature with the technology, and the machine speed is not a problem. The algorithm today is similar as 20-some years ago. So the algorithm is not a problem. The first thing to tackle, we all say, oh, let's get the data and the AI machine learning. It's not that. You need to go lower layer, right? First you say, how do I process these data? Are these the right way to collect this data? The telemetry, the in-memory processing, all these things are the important things. So you go down to the level of how do we, automate many things before we can really driving. I mean, I would say self-driving network, in a sense, more difficult than self-driving car because, well, there's no that same safety, but self-driving car, what you need to do, you have a sensor, you got all the pictures in front of you, around you, back of you, right? You have a navigation to tell you where to go. The network is distributed. That one is limited space to worry about, to process, right? And we know the networking is not like when we do speech recognition. You got labeled data all over. You can buy them, you can whatever, right? Image, all these are available. Networking, no labeled data. So you mentioned the supervised, unsupervised learning, all various things need to combine together. But we can use certain, maybe not exactly math, right, to figure out things. Basically, what we're trying to do is to learn the pattern. Because everything at the end, long before we do AI, is a pattern recognition, right? You do all these things, it's pattern. We want to establish the baseline pattern, then you see this is an attack pattern. This is falls through the cliff. I'm
I
done.
think the comments are very interesting, but we have still
Some
a presentation to do.
Yeah, I'm done.
Just a conclusion about your comment. Because
My comment, this is the right direction, and we have a lot of layer work to do before we worry about which algorithm.
okay.
Okay,
To
thanks.
telemetry, collect the data, get the right data, infrastructure.
Thank you.
Thank you again, Laurent.
Security, thanks a lot. I think it triggered nice discussion. Yes, please, gentlemen,
Yeah,
very
I just
quickly.
have one remark. If you want to get there, I listen to what's saying here. We have to change our mind regarding, networks operation, because what I try to say that the network know everything. So if you're looking about car, for instance, the switches, if actually today, the thing that we are debugging network, for instance, just if something is not working, we are sending ping for the management station. It's like if the car is not driving correctly, somebody send from the central office of, I don't know, of Google, a packet to the car and see if why the car is not, driving in the right way. So what I try to say that the switches, the networking know everything. And if we can get more information for these devices, if you have degradation in the service, the switch know it. The switch know that you drop packet, for sure. So we have to think differently if we want to get to this,
That's the LiDAR.
Yes, that's the lighter, exactly. This is the lighter, not the management.
Thank you. Okay, we have a presentation still, and I'm not sure we will have time to discuss after that, but
I try to
It
do my
was
best.
already part of the objective of this discussion.
So good afternoon. My name is Jefferson Nobre, and my job is easier than from the previous speaker because I'm going to talk about the past. So I'm going to talk a little bit about retrospective about autonomic networking, and it's not. I know it's an ambitious title for the presentation, but it's more like the retrospective considering the efforts on the IETF. Oops. The outline is a little introduction, autonomous networking at the Nmrg, the ANIMA working group, and the outlook. Next slide. So it's a known set of properties of that we expect in an autonomic system, and sometimes it's easier to say which are the properties that are expected than to say what is an autonomic system. But usually it is expected to be automatic, adaptive, and aware. In order to define that, there are some different set of properties that are used. So, for example, you have the self-chop or the MAPK, and there are others. But for our concern, we think that an autonomic networking system is the application of these kind of properties in the network lifecycle. So, for example, we can talk about the installation, the commissioning, the operating, like the monitoring, and this kind of jobs in a network operation. So, as usually, it's necessary to have some adaptation in autonomic networking system. It's usually used some kind of a closed loop control. So this is a simple sketch from the Focal system, which is a influent autonomic networking management system. And the important thing in the figure is that it has two different components. The autonomic manager, which collects information from the network and also acts changing, for example, the configuration of autonomic managed resource, and the managed resource which provide information for the manager. Next slide. So the autonomic networking was the subject of several research projects and investigations in the last few years, in the last decade. So, for example, there is an UMF, GANA, and others. And also, considering the work in the IETF, there are some efforts. And for example, we can talk about some efforts in SUPA, HomeNet, SDNRG, NFVRG, in the I2RS. So there are lots of interesting. And also, and this is what brings me for this presentation, the autonomic networking investigations is usually addressed by the network management community. So, for example, we can say about works that are published in IEM, NOMS, CNSM. So, at this point, we can say that from a network management perspective, autonomic networking is something of is a subject of interest. In this regards, there are lots of meetings of Nmrg that are focused on autonomic networking management. So the first one was in Vancouver. Huh?
Just speed up a bit on.
Faster? Okay. So there are the first one in Vancouver, the second one in London. Next slide. The third one in Toronto, and also there is a meeting which was held in Rio de Janeiro in the CNSM 2014, which is also there are presentations on autonomic networking. Next slide. In these presentations, there are lots of works considering the definitions of autonomic networking terms, and this leads to two drafts, and that are now RFCs, which are a set of design goals and no goals for autonomic networking, which is the RFC 7575, and also the gap analysis of autonomic networking, which leads to RFC 7576. And these two works, these two documents, lead us to the UCAN-BOF, which is an important outcome of the Nmrg work. It's about for the use cases of autonomic networking. And these are the docs that appeared in this BOF, which are from background on autonomic networking, some use cases, and some works on the solution space. Slide. So after that, the ANIMA working group was charted, and this text is from the charter of the group. We have a definition of the outcome of the ANIMA working group as a system of autonomic functions that carry out the intentions of the network operator without the need for detailed low-level management of individual devices, which is, I think, it's consistent with the slides that the previous speaker showed us. And also the goal is, as is charted in the group, is not to have a complete solution for full autonomous networking, but a specification of a minimum set of reusable components to improve the operation of networks. And the focus in the working group is to have is to work with professional management networks. Okay, so there is in the charter 4 items for protocols to be developed, and also there are 3 works that are developing such protocols. And for the discovery and the negotiation of autonomic nodes, we have the GRASP from Brian, which I think it's here, I don't know. There's also the bootstrapping of a trust infrastructure, which is addressed by the Brisky, and also the development of an autonomic control plane, which permits the communication of the autonomic device, which is known by the ACP. Okay, so as there is a limited set of functions that are defined in the charter, because it's important as an ambitious goal, it's important not to boil the ocean, but to have a more focused, specific work for interesting and feasible points of autonomic networking. There are some work which is out of scope that was presented in the UCAN-BOF and after that, and which, for example, can talk about policy intent, use cases, or autonomic service agents. And this, in the charter of the ANIMA working group, is stated that this work is encouraged as individual submissions or Nmrg submissions. So it's recognized that as an outcome of Nmrg is a good place to work with interesting work of autonomic network, but which is outside the scope of the working group. So right now there are some uncharted work that remains in ANIMA, waiting for new phases or the recharter of the group. So for example, there are works on coordination, the intent, format, and distribution. And there are also other works that are from the UCAN-BOF that are still in the Nmrg. And for example, there is this work about distributed detection of SLA violations, which are one of the authors of this draft, which is in our working group Let's Go, by the way. So finishing, I think that I'm doing really quick this, but the definitions and the goals and the gap analysis of the autonomic networking probably need more consideration considering the IETF, and we think that maybe the Nmrg is a good home for this discussion, this kind of analysis. So for example, there is an internet draft about the autonomic networking definitions, which is this, it should be complementary to the RFC 7575, and it is on the state maybe, as we said before. So I'm one of the authors of this draft, but we're looking for new contributors. So if you want to work on that, you are welcome. And there are some other points that maybe also can use Nmrg as a home. For example, machine learning. Né? As said before, as presented before, it's also something which is really important considering self-star or autonomic systems. And besides that, we think that maybe the definitions of autonomic networking are previous from the wave of network machine learning. So probably there's some room for investigation, try to compatibilize both areas. There's also the works on intents, which I know it's kind of a controversial topic, but currently it's out of scope of ANIMA, and I think also it's out of scope of SUPA. So maybe if you were interested in writing down something about intent, Nmrg can be possibly our home for that. Also, the programmability of networks, for example, considering SDN and Nmrg, also are an interesting input for autonomic systems. And also, we know that there are lots of interest in this kind of network approach. We can see as, for example, the interest in SDNRG and FVRG working groups, research groups, and works on that also can be done considering, for example, management aspects in the Nmrg. I think it's okay. So, as my last words, the deployment of new technologies is typically time-consuming and labor-intensive tasks. So, and I'm saying that because it's important to concentrate the energy to do that, and maybe the Nmrg can do this kind of stuff, you know, like a place that different works considering some different portions of autonomic topics can be joined together in Nmrg.
Thanks a lot, Jefferson. I think we are really finishing the session, but I would like to take a couple of minutes just to reflect on what we have discussed today. I really like the presentation and discussion we had. I think, at least on my notes, I identified a set of key points of discussion. We came back regularly on that. I mean, where should we start? What should be the end point of this self-driving network, autonomic networks? We have ongoing work either in Nmrg, ANIMA working group, and other groups even outside of IETF, IRTF. So I think there are still some interesting topics that we could tackle in this research group. What I would like to invite you is really to express, we don't have time right now, but maybe you can go to the mic, that what will be the first steps we should take in the research group to say, do we start a new document, which topics we can, subset of topics we can identify, what concrete actions we can take to really try to bring this work forward, not just to have this discussion, but to have also follow-up of this discussion. So I don't know if anyone wants to propose something, what would be the next step, how you want to work.
Well, taking into account that Jefferson has named a couple of things that I mean somehow involved with, I think that the point here is that we have several, I mean, places in which we have many touch points, and there are a lot of fuzzy zones in which you can end on one side or the other. Probably it would not be the bad idea to start by trying to identify gaps and challenges and which are the directions to move. You know, I mean, in a document that we can discuss on, rather than sharing ideas, because it's something that, well, I can agree with. For example, what you mentioned is about the programmable networks. I mean, the programmable networks in general, where you have NFV on the one hand, you have whatever is called SDN, I mean, SDN or the like, software networks in general. And this is something that whenever we move, there will be this position in which whether this is software-based networks, whatever, or we're talking about software-based network management. It's a little bit, if you think in the same terms, when you have an operating system, you have the applications running, and then you have the other things that are managing the system that are applications at the end. Well, drawing the line is challenging anyway, but it would be interesting to have some kind of document to discuss on.
To structure a bit.
Let's call it challenges or research directions or whatever, but something like that. And I would be happy to be part of it anyway.
Thanks, Diego.
Kiriti Kompella. I would be really interested in two things. One is, I talked about standardized data models, but I think it's very important to have data models to play with them and not to have a standard necessarily, but to have an evolving standard. As we understand the data better, I know that other people who've worked with telemetry have said, oh, this is a great data model, and then they realize that it's not the best one, then they have to keep changing it. So that sort of fits better in an RG rather than an IETF. And the second thing is, can we have a repository of data? Data is very hard to find. People are scared about sharing data. But if we can have a repository of data, then people can say, let me use that data and try some experiment that I haven't tried before. So there's a thing called Kaggle, which Google just bought, by the way, just so you know. There are repositories of pictures of, and so if you want to recognize a cat, rather than downloading a million things from the internet, you can download this set of data and run your algorithm and say, are you better, are you more accurate, or whatever. So so if we could find repositories, or if we could build repositories of data, network-oriented data, that people could then say, let me try correlating this and that, or let me try something else. Because that's the foundation. And I should repeat, I don't want to do machine learning. I want a self-driving network. Machine learning, I think, will get me there, but I'm open to anything else. The goal is important, and then the technology comes afterwards.
Okay. Thanks, Kiriti, for the suggestion. Additional final comments? We're already a bit over time.
Then I'll make it fast. So John Strassner, Huawei, I'll be happy to work with Diego and others on this. I think there's a couple of very important things that we need to work on, or else marketing will try and define it for us, and we'll be stuck with trying to implement it. And as an architect, I really dislike that. The first is intent. Everyone is talking about it. It was everywhere at the MPLS World Congress. And it's very, very misunderstood. So I'm also the orchestration area director for the MEF, and we're working on a definition and solution, and perhaps we can share that here in Nmrg and get a wider view on this and uptake. The second is, unlike Coretti, I actually do like machine learning. I couldn't resist. Sorry, Coretti. Yeah. I forget the person from eBay, June or Julie or whoever. Yes, you. You on? Oh, okay. Sorry. I've got bad hearing. But, one of the interesting things in deep learning is that distinguishes it from prior types of learning is that it doesn't have to be homogeneous, right? So as I build my layers of machine learning, I'm free to use different abstractions and different mechanisms from layer X to layer X plus 1, which you can think of as allowing different algorithms to provide fine-tuned parts or pieces of the aggregate whole, right? I mean, this is true for any type of ensemble-based learning. But More importantly, none of this is going to work, not just without a standardized data model, because you'll never get a standardized data model. It's physically impossible, right? Because you've got to take into account the limitations of protocols and languages and formats from these different data sources, right? I mean, so instead of that, I actually think you need a standardized information model, and maybe not a homogeneous information model, but rather fragments that can be used, much like you use ontologies to assemble learning systems that serve as the base for different domains. So this is a working group
Just a
topic, but
quick clarification, because I mean, we have been through information models and data models a lot of time, I think, over time.
yep.
What you're suggesting is more to have this work more linked to the machine learning. I mean, combining the definition of an information model that will be useful for data representation for machine learning.
So InfoCal, which Jefferson kindly referenced, thank you, we used models to represent facts and ontologies and first order logic to add meaning to those facts so that you could then build a grid or a semantic network that described the impact of what a particular datum or series of data meant on the rest of the system. In order to do that, we had to be able to normalize things like IP-based data with audio data, with pressure-sensitive plates, with all these things that probably weren't even on an IP stack. And so it doesn't matter if it's JSON or protobuf or foobar as a data encoding. Who cares? If you fundamentally cannot agree on what a customer is or what an alarm is, you got a much bigger problem. And that's why you need an information model. And I know that's not popular in the IETF and tough. I mean, pay me now or pay me later.
Okay. Thanks a lot, everyone. I would like to free you for this evening. We will follow up on the mailing list. I think from the minutes, we'll try also to extract some set of action. And I really would like to see that the volunteers to work on the structuration of documents will follow up. Thanks a lot for your time and attention. Thank you. Bye.